linked list, right? What is doubly circular linked list? For that, this thing we have already discussed the introduction of this list when we were discussing the types of linked list. So you can check out that video here in this I button. Fine. See, this is what a doubly circular linked list. In this video, we will see how to implement this list, or you can say how to create this list and how to traverse this list, or you can say how to display the content of a doubly circular linked list. See, as the name suggests, it is having the property of both doubly and circular linked list. So as you can see here, see, this is what a doubly linked list. Each node is having 3 parts. One is data part and one is pointer. This is pointing to the next node. This pointer is containing address of the previous node, right? Now, how to add the properties of circular linked list? In circular linked list, what we have discussed, the last node would contain address of the first node. As you can see here, the next pointer of this last node is containing address of the first node, that is 500. Fine. So there is a link like this to this node. Plus one extra property of this list is what? This is known as doubly circular linked list. Here, the previous pointer of the first node would also contain address of the last node, right? The previous pointer of first node. See, here the 600 is there and 600 is address of the last node, and here the next pointer of the last node would contain address of the previous node, right? So in this list we don't have any null pointer, right? So this is what a doubly circular linked list. Now in this case we have maintained both head pointer and tail pointer. Head is containing address of the first node, tail is containing address of the last node. If you maintain only head node, then also you can create this list. See, this link is bidirectional, right? Rather than creating 2 links here, I made this bidirectional link. So this to this also and this to this also. Fine. Now we will see how to create this list, right? How to represent this node of the list. That thing I guess we already discussed when we were discussing doubly circular linked list, right? So initially we assume that list is empty, we don't have anything in the list, right? It means you can say head is equal to null at starting, right? See how you will create this list. So this is how we are going to define our own data type. That is how to represent this node, struct node. 3 parts are there, data parts, next pointer and previous pointer, right? How much memory would be allocated? 4 bytes for this, 4 for this and 4 bytes for this. Pointer would be allocated 4 bytes because in 32-bit compiler, if 64-bit compiler is there, then 8 bytes would be allocated. So total 12 bytes block is there, right? We are maintaining 2 pointers, head and tail, right? This is what we will define a data type globally outside of all the functions. So now we are going to define this function, that is create dynamic this doubly circular linked list, right? So obviously first of all we think that we assume that the list is empty. So for inserting the nodes, we have to create this node, right? It means you have to allocate the memory to this node. And how you are going to allocate the memory? We use what? Dynamic memory allocation in linked list, right? Why we use dynamic memory allocation? That thing we have discussed when we were discussing introduction to linked list. You can check out that video here. And how we allocate the memory dynamically using malloc function. So I guess everybody knows how to write down that syntax. We have discussed many times, right? So at starting I write here head is equal to null. It means there is no list. We don't have any list, right? Now I am going to create a node, and the pointer of this node, the address of this node I am going to store in another pointer, that is a new node pointer. I have created a new node pointer. This new node is pointer to node. That is why I am writing here data type is struct node, right? So now what you will do, how you will write this? So this is the situation. Now we have created a node, we have allocated the memory to this node using malloc function, right? Malloc size of, how much size? For this struct node, for this node. So that is why here in bracket we will write struct node. 12 bytes would be allocated. Address of the first byte is 500. So malloc would return what? Pointer to the starting address of this node. But malloc will return void pointer. That is why you have to typecast this thing. Because this new node, in this new node I'm going to store this address, and this node is what? Pointer to node, right? So here you will write struct node asterisk. We are going to typecast this thing, and whatever this will return in new node I am going to store this, right? Now I'm going to ask from the user for the data, right? Which data I want to store here. So this is how we are going to store the data, right? Printf enter data, scanf percentage %d, where I want to store data here. So how you can access this part of this node? We cannot directly access structure members. You need a pointer to this node. Pointer to this node is new node, address of new node, and name of this is data part. So here I am writing arrow data part. So suppose user has entered 7, right? Here you can store 0 and 0, means null and null, but no need to store here because we are going to update both the pointers, right? So you can leave it like this. Now at starting we check what if head is equal to empty, it means, sorry, if head is equal to null, it means there is no node in the list, right? So then how you are going to insert this node in the list? See now, both head and tail would point to this node because this is the first node, this would be the last node only, right? So here what I will write, head is equal to tail is equal to new node plus, now see, both this tail is also pointing to this node and head is also pointing to this node. But now you have to insert here also something and here also something. Now what? We have discussed the next pointer of the last node is containing address of the first node, right? So this pointer would contain, this is only the last and first node. So here we have to insert 500, address of itself, right? And here also the previous pointer of first node is containing address of the last node, right? And this is first and last node, so here also you will store 500. Now this would be the doubly circular linked list. So now how you can access this part? See, tail, new node and head, all the three pointers are pointing to this node, so you can access it using any pointer. Suppose I am writing here head of next equal to head, that is also fine. If you write tail of next equal to tail, that is also fine. If you write new node next equal to new node, that is also fine, right? And now head, third thing, head of previous, this thing is equal to head, right? So now this is done if there is no node in the list. Else, if we are having some node in the list, suppose one node is there and now I want to insert a second node, this node, I have created a second node and user has entered suppose 6 here, right? So now in that case, this new node, suppose address is 600, so in new node, now this new node is having 600 address, right? So new node is pointing to this node. We are going to run this code again, right? This one. Again we are going to create this thing and whatever this will return, we are going to store in new node pointer, right? Now I want to store this node in this list. Now in this case, head is not null. So now, how many pointers you need to update? Here you need to update, I guess, 5 things. See, this would contain address of the next node, the next pointer means 600. Second thing, this would contain address of previous node, that is 500. Third thing, now this would contain, this would be the last node, so this would contain address of the first node, that is here also 500 you need to store. Plus you need to update this thing also, because the previous pointer of the first node would contain address of the last node, that is here you will store 600. Plus fifth thing is, now tail would point to this node because this is now the last node, right? So now how you will write down that thing? See, in this case also you need to take care which line you need to write first, right? See, now here I need to store 600, address of the next node, right? 600. So how you will access this part? Tail is pointing to this node, tail of next. So here I can write tail of next. See, we obviously here head is also pointing to this node. So you can ask, can we write head of next? No, we cannot write head of next, because after inserting second node, if you will insert the third node, in that case here you need to store address of this node, right? And how you can access this part? Because after that tail would be pointing to this node using tail of next. We cannot move this head, head will always point to the first node. So better to use tail node, right, rather than head. We cannot use head. Tail of next, here 600 I want to store. From where I can get 600? In new node I have 600, right? So now this is pointing to this node. This is not pointing to itself now. So now this node, here we will store address of the previous node, right? The previous pointer of this node will contain address of the previous node, right? How you can access this part? New node preview. So here I will write new node preview, because pointer to this node is new node. What I want to store address of previous node, that is 500. So in tail we have 500, so I will write here what? Tail. See, here also we will not write head, because head is also containing 500, but we will not write here head, because head will always contain address of the first node, but when we will insert third node, in that case we need address of the previous node, means this node. In that case tail would be pointing to this node, so we use here tail, right? So here I have now 500. So now we have set 2 links. Now you need to update 2 links more. See, this last node, this is the last node now. So this node would contain address of the next point of this node would contain address of the first node, to make it a circular list, right? So now how you can access this part? Here I will write new node next. Address of the first node we will always find in head pointer. So here I will write head. In head we have 500, so 500. So now this is pointing to this node, right? Plus you need to update this thing also. The previous pointer of the first node. How you can access the first node? There is always a pointer, that is head. So here I can write head of prev. Address of the this node, last node. So here what you will write? New node, right? Because in new node we have 600. So here I can write what? Now it will contain 600. So now this is pointing to this node. So I am making this a bidirectional link, right? This and this. Now another thing you need to update, now tail would point to this node. This would be the last node. So in tail we will store 600. From where I can get the address? New node is containing 600. So here. So now this is having 600 and tail is pointing to this node. So this is, as you can see, we have inserted this node successfully. Now suppose if you want to check out these lines are working properly or not, here you can create another node, third node. Suppose user has entered data -1 and this is what? The address is 700, and so in new node we have 700 now. So a new node is pointing to this node, right? Now I want to insert this node in the list, right? So now if head is equal to null, that is not true. So we are going to enter into else part. Now see, tail of next, in else we have written tail of next, means tail of next, tail is pointing to this node, that is this one, is equal to new node. In new node we have 700, that is, now this is pointing to this node, that is fine. New node previous, here I will store tail. In tail we have 600, so 600. So this is the address of previous node, so that is also fine. This is pointing to this node. Third thing, new node next, this data, this part is equal to head. In head I have 500, that is 500. This is now pointing to this node, right? This node. Fourth line, head of previous, means head is pointing to this node. Head of previous means you are accessing this part, is equal to new node. In new node I have 700, so here 700. So this would point to this node. So I'll make the link bidirectional, right? Fifth, tail is equal to new node. In new node I have 700, so here now tail is pointing to this node. So now after this you can write down that same while loop, here you can write printf, press 1 for continuation and press 0 for exit. So here you can write scanf %d, and the user choice you can take out in a variable, you can say choice. Here you need to initialize the choice is equal to 1, right? If user press 1, the again node would be created, right? So now for creation, these lines, after that these lines should be executed again and again. So we will write this code into a while loop, while the variable is choice, and after that you will start while loop, and here you will end this while loop, right? So before closing this while loop you will write what? Printf, press 1 for continuation, 0 for exit, scanf %d, address of choice, right? Now if you want to cross check that we have created this list or not, then see, here I am saying the next pointer is containing address of the first node. So can we print using this pointer the data of first node, right? So before closing this create function, you can write what? Printf %d, and here you can write, see, tail, the pointer to this node is now tail is pointing to the last node. So here I can write tail of next, right? I will access tail of next. So and data, again pointer and data, so it should print what? 7. Using this tail I'm printing this first node, right? As well as you can print using head, using the first node, can we print this data? So again you can write here head of previous. See, this previous is containing address of the last node. So second thing what you can write here, head of prev, it means 700 means we have reached till this address, and again arrow data, it means -1, it should print -1 and it should print 7. So this is how we have created a doubly circular linked list. Now we will traverse this list, means we are going to display the content 7, 6 and -1. How you will write down that code? See. So this was the list we have created. Now I want to define a function that is display. How to display the content of this list, right? So obviously for displaying or for traversing we need a pointer that we can move, because head will always point to the first node, tail will always point to the last node. We cannot move these pointers. So here we need a third pointer, you can say temp pointer, and initially this temp would point to the first node, means in temp we are going to store head, right? So now this is what? A temp pointer. In temp we have head, that is 500, so temp is pointing to this node, to the first node, right? Now you will check if the list is empty or not. So here what you can write, if head is equal to 0, head is equal to 0 means you can print list is empty, there is no data in the list. Otherwise in else part what you will write, now we will print this head data and move this temp, print this head data and we will move this temp till what? Till we reach to the last node. So what is the termination condition? When temp would point to this node, it means temp becomes equal to tail, right? Because tail is containing address of the last node, and at some point of time temp will also contain address of this one, that is 700. It means we have reached till the last node, then we are going to stop, right? So now in while loop what you will write, while temp not equal to tail, in that case we will move until we will move. So temp is pointing to this node, so first of all what you will print the data, print a %d temp of data, and after that we will move this temp, right? Now temp will point to this node, that is 600 we will store in temp. So in temp we will store temp is equal to temp of next, temp of next. Now see the working of this while loop. At starting temp is 500, temp is not equal to tail, tail is 700, condition is true, so we will enter into this loop, printf temp data, temp of data is 7, temp is equal to temp next. Now see, in temp next we have temp of next 600, so in temp we will store 600. So now this is pointing to this node, right? Now again check, temp not equal to tail, temp 600, tail is 700, yes, condition is true, we will enter into this loop again printf temp of data, that is 6. Now temp is equal to temp next, in temp next we have 700, so here now we will store 700. So now temp is pointing to this node. Now check the condition, temp not equal to tail, temp is 700, tail is also 700, means we have reached to the last node, right? But see, condition is not true now. So we will not enter into this loop, control will not go into this loop, control will go out from this while loop here. But now the output is only 7 and 6, we need to print this data also, right? So here after this while loop you will write one more line, that is %d, and how you can print -1? See, temp is pointing to this node, so temp of data, here you can write one more line. After that close this else statement, and after that this function, display function. So this is how we are going to display the data. But if you don't want to print the last this data separately, then what you can do, rather than this while loop you can use do while loop, right? Here you can use do, because these statements would be executed first in do while loop, and after that condition would be checked, right? After that you can write this while condition. That thing do while loop also we have discussed when we were implementing the circular linked list. So how to write down do while loop, that also you can check out in the I button for that video. Fine. See, here in the termination condition, if you don't write this thing, then you can also write a second termination condition. See, temp of next, when temp of next becomes what? This tail of next, Tail of next is always containing address of the first node, right? So it means we have reached to the last node. So while camp of next not equal to tail of next, till then we are going to move, otherwise we will stop, right? This condition you can also write. So this is the implementation of a doubly circular linked list. Fine. In next video we will see the insertion operation in doubly circular linked list. Fine. Insertion at beginning, at end and at any specified position. So I'll see you in the next video. Till then, bye, take care.